One-way analysis of variance is a very important building block for more complicated statistical models. That's because what it does is that it partitions the variability in our data set to that across groups as compared to that within groups. To put it another way, one-way analysis of variance acknowledges the hierarchical or nested structure of the social world in which we live. This is why it's often used by social scientists in many different kinds of analyses, not just for examining different experimental conditions. Let's look at an example from sociology and political science. In the 1950s, a famous sociologist named Otis Dudley Duncan, he found that occupations in the United States, they differ greatly in their level of prestige, meaning people evaluated occupations in different ways. They would say, oh, being a professor is more prestigious than being a car mechanic, for example. He wasn't saying this in a normative sense. He was just saying if you ask people in the population what they think is more prestigious versus another job, there are different levels of prestige. And his point was that this prestige, it may not be related to the actual skills or value of a particular job or occupation, but it does confer certain social advantages and benefits. That's why he was interested in this idea of occupational prestige. In particular, he measured prestige as the percent of people in the United States who rated an occupation as excellent or good in terms of prestige. So he just handed out surveys and said, do you think this job is prestigious? Excellent, good, fair, or poor? Then what he did is he categorized these occupations into these three different groups. He said, well, occupations with this kind of prestige or blue collar, with this, based on these levels of prestige, these occupations are white collar and these occupations are professional. He was talking about the 1950s and 1960s, but the idea is that you have these different sets of occupations with different levels of overall prestige. Now we might ask, do occupational groups really differ in their level of prestige? So we have these three different occupations, or sets of occupations, blue collar, white collar, and professional. And then we have this outcome, this continuous outcome, which is prestige. So what we can do is we can use the one-way analysis of variance to examine if occupational prestige differs across groups. This is you can really think of it as what's called a strip plot. We have these three different groups, blue collar, white collar, professional, and then we have all these occupations within each group. Right? There are a bunch of blue collar occupations, there are a bunch of white collar occupations, there are a bunch of professional occupations. For each occupation, right, each occupation has a particular level of prestige, which is a continuous variable. Then what we can do is we can say, well, do the means of these groups, do they really differ from each other? Right? So we can conduct a one-way analysis of variance. The null hypothesis is that the means are the same for each set of occupations, white collar, blue collar, and professional. The alternative is that they're somehow different from each other. Well, when we conduct a one-way analysis of variance, we find that the probability of obtaining a test statistic or an F ratio as more extreme than the one we obtained is almost zero. What this suggests is that we can reject the null, that the population means are the same for each group. To put another way, the occupational prestige for each of these sets of occupations, they really do differ. In particular, it suggests that the professional class has a higher level of occupational prestige on average than the blue collar and the other sets of occupations. We can also visualize this. Again, the null hypothesis that all population means are equal, it implies an F ratio of about 1. And this is just the F distribution model based on 2 degrees and 42 degrees of freedom respectively. The F test statistic, it's off the charts. Right? It's enormous. So the probability of obtaining a F ratio as or more extreme than the one we obtained is almost zero. So we can reject the null that these three sets of occupational clusters, that they are from the same population, that they have the same mean occupational prestige. The underlying point here is that we can use analysis of variance to examine the hierarchical nature of our data. We can also use it to understand and compare different group means. The key insight of analysis of variance and why it's so important is that we can partition the variability in our data in terms of that which is across groups, how different are groups, as well as in terms of that within groups, how different are individuals within each group. In sum, we can say that the total sum of squares equals the within sum of squares plus the between sum of squares. A few things to know about one-way analysis of variance. It's used to test the claim that multiple population means are equal. The main assumption from analysis of variance is that the population variances are the same for each group. When we assume that the population variances, the spread, are the same for each group, then the differences we can attribute to these different means. Another important part about one-way analysis of variance, and why it's an important building block for other statistical models used in the social sciences, such as multi-level or hierarchical models, is that one-way analysis of variance is based on decomposing or partitioning the total variation in our data in terms of that within and between or across groups.